All right, so next up, we're going to do an example using the inverse of that step function property. I had already written it down, and then I managed to turn the whole screen off, so I restarted. But now we're just looking at something where we do L inverse of e to the minus as f of s gives us that little f of t minus a, u of t minus a. And the problem we're going to do is just trying to find L inverse of 1 over s minus 4 e to the minus 2s. And sort of looking at this, I guess we could rearrange it in the order that the property was given to us. You don't have to do that kind of thing. But so here we can see that a is 2. And then here we can see that our f is e to the, our f is 1 over s minus 4. So our little f would be e to the 4t. And let's be even more clear, our little f of t would be e to the 4t. So then a little f of t minus a would be e to the 4t minus a. But our a is 2, so e to the 4 times t minus 2. I don't know. I like to write out all that information first, and then it's easier to see where all the pieces go. You don't have to do that when you're working through these, though. But we know that L inverse of e to the minus as f of s is going to be f of t minus a, u of t minus a. So then for us, that's just going to be e to the 4 times t minus 2, u of t minus a, so u of t minus 2. And if you wanted to write that as like a piecewise function, you could. That's just going to be 0 up until t equal to 2. And then after t equal to 2, it's going to be e to the 4 times t minus 2. Like that. We could do one more of these inverse examples, I guess, because they'll go pretty fast. If we were trying to take L inverse of s over s squared plus 9 e to the, what is that, minus 11? Oh no, minus pi over 2s. There we go. So that's in the order we're used to looking at it, L inverse of e to the minus pi over 2s, s over s squared plus 9. So our a is pi over 2. And then our f is s over s squared plus 9. That means our little f of t was, so you had an s squared plus 9, so it's some kind of trig function of 3t. And since there is an s on top, we know that that's the cosine one. I know it's a 3 because that's k squared is 3 squared is 9 right there. So our f of t minus a, we'll do it right here. F of t minus a would be cosine of 3 times pi, t minus pi over 2. So taking this inverse is just going to need f of t minus a, u of t minus a. So that's going to be cosine of 3 times t minus pi over 2 times u of t minus pi over 2. I didn't put box around the other answer, but I will now. And again, if you wanted to represent that as a step function or as a piecewise function, that's just 0 until t is 2. And then after, t is pi over 2. And then after pi over 2, we're going to be cosine of 3 times t minus pi over 2. So the inverse direction of taking these is actually not so bad. It's really, in a whole problem, identifying when to take the inverse, and then the problem of actually learning how to write the thing that you take the forward Laplace transform of in the shape that matches the f of t minus a, u of t minus a. So we're just going to recap on that real quick. I'm just going to give you a general rule. So for some f of t equal to g of t for 0 less than or equal to t less than a, and h of t for t greater than or equal to a, is that you can write f of t is equal to g of t minus g of t times u of t minus a plus h of t times u of t minus a. And then you can follow the same rule for when g or h is 0. So if you're looking at like it's 0 and then becomes some h, or if it's g and then becomes 0. And I just want to kind of like highlight what's happening in all these parts. So this g of t right here is accounting for when you have g of t below a. And then this minus g of t u of t minus a is take away g after a. So after a, right here, there is no g, so it's taking that away. And then this plus h of t u of t minus a is adding on h of t for t bigger than a. So I'll write that in words right there. And then before we had only g when t was below a. And then real quick, I'll just write down that this would work for g equals 0 or h equals 0. You just plug in zeros. If you want to have f of t equal to 0 and then some g of t and then 0 again, at breakpoints a and b, what you're going to have is that f of t is equal to g of t times u of t minus a minus g of t times u of t minus b. And what's happening here is that the g of t u of t minus a represents these two parts. And then the minus is just taking it away right here. So that you end up at 0 afterwards. So those are those two formulas to kind of help you with that, setting up the piecewise function for taking the Laplace transform part of these problems. You don't have to memorize those general formulas if you don't want to. Personally, for me, it's easier to just kind of reason through it. Oh, no. Reason through it the way we did in these examples. But there's like a generic version of it for you, just in case that's helpful.